Good morning. Welcome to the 2020 Snap4City course. This course is presented from the 14th to the 16th of April in 5 different sections, with and includes 7 different parts. So the full course is describing what is the Snap4City infrastructure and services and tools for creating smart city solutions, and so the Snap4City, as depicted in these slides, has been developed in the past, starting from the KM4City facility and tools, and it is 100% open source. There is a business model available on the portal. It is GDPR compliant, has passed the penetration and vulnerability test, is part of the European Open Science Cloud, so you can install on cloud. You can ask to us to deploy a new instance on cloud for you, or you can install from yourself on your premise or on your cloud virtual machine or Dockers for the installation. These parts are described in the system part, which is the part number 6 of the full course. So let's say that we could start with the general overview of the Snap4City platform. So I am going to use some of some notes with the pen, and also some demonstration in the slides, so they will be used in the several parts. So the meaning of Snap4City means a scalable, smart analytic application builder for Sentence City, with the support of the Living Lab and co-working with the stakeholders. So it has been developed with the aim of supporting the city with a Living Lab tool, with an infrastructure on which all the stakeholders can work together to make the city smarter and smarter every day. So you can share these slides with your customers or your colleague. They are available on the page of the course. All things and test cases are available for free, so license free. So is I would remark that Snap4City is license free. So there is no license to use the tools that are available on GitHub, and it's fully 100% open source. Apart from small specific algorithms and data analytics for complex tools that I am going to remark which of them are proprietary and are provided in license, and sometimes provided in license even with the open source. But only few small restricted parts, and no parts of the platforms, no functional part is blocked by any license or any fee that you have to call. So presently, the coverage of Snap4City is in Europe is described in these slides. So we cover the center and the north of Italy, with the whole Tuscany, a large part of Garda Lake, and also a part of Lombardia, and so on. We are also present in Finland, from Helsinki mainly, in Belgium with Antwerp, but we collect data from almost all regions. We are in France, Occitanie. We are just started a few weeks ago. We are going to have also in Spain. In Spain we have Santiago de Compostela with traffic flow and others. So we are going to be also in a short time in Greece and in Croatia, and etc. in Dubrovnik. We have also data and service in Sardinia. We have a number of hubs, 3 hubs in Tuscany, in Italy, and 1 in Antwerp and 1 in Helsinki. So the structure of the whole course is depicted in these slides. We are in the first part, a general overview. The second part is dedicated to dashboard creation and management. The third part on developing IoT application. So in a view also of to understand which kind of devices and network can be connected to the smart city infrastructure based on Snap4City. The fourth part is dedicated to data analytics and big data. Data analytics can be done in RStudio in Python mainly, but also in other language. We are going to explain you how to exploit and manage data analytics in IoT application to make smarter your solution. The fifth part is related to data ingestion, data warehouse, how to ingest the data from IoT, but also from open data, from GIS, from external services and others. The sixth part is describing more in depth the architecture and how to install a Snap4City on your premise. Which kind of configuration we can have regarding Snap4City, how modular is, how scalable is. In the seventh part is regarding the Snap4City APIs that are used. There are 2 versions, one for internal use, one for external use. So those that are external can be exploited by web and mobile application using a development kit that we provide in open source, or developing your mobile app from scratch, just using the facilities and the API. You can integrate your mobile app that you have already in place in your area with exploiting the Smart City API we provide. So, a number of training sections of reported above are going to include exercitation, demonstrations, and other interactive tools. So the slides of the full course are available in at this link, so you can access them. And we are going to publish also the recorded video from the presentation we gave. I am in this moment recording this exact presentation that I am going to expose you. So you can also to access to the Italian version of the course and also to the 2019 version of the course that is available in the 501 page of the Snap4City portal. The 2019 course has been deployed during the Smart City World Expo Congress in Barcelona last November. So the structure of this part is going to be accessible from the slides, even in an interactive manner. So you can click on those buttons on the left to go directly on the section of your interest in the interactive version of the slides in the portal. So the structure of this part agenda is described in these slides. So overview, a little bit about the urban platform, a more in-depth view regarding the Snap4City architecture, dashboard, example of dashboards with a connection with the IoT application for real-time, dashboard intelligence, dashboard for smart city control rooms, and also mechanism for data gathering, and how to use the IoT application. Just an overview. Most of those aspects are just listed as an overview. Also for creating web app, data analytics, living lab, and the list of projects and challenges that are presently under development or already developed exploiting Snap4City. So, and the list of acknowledgements. So this overview is describing the whole course overview, the whole platform, but you have to jump to specific section to see more in deep details and to learn how to use the tools that we provided. So we start with the overview, general overview with the cases, with the city or other application that have been developed by using the Snap4City technology. The main concepts behind Snap4City is described in these slides. So the whole data that we collect represent the elements in the city, and they could be devices or GIS information or whatever you have in the city or in the industry that for us are just data. So you can imagine that you may have any kind of data or any kind of stream of data arriving in the platform through brokers or external service or whatever. And even your personal device can be attached to the system. All this data arrive inside the platform and can be stored in the data shadow, in the storage, and can reach even directly the dashboard and the user interface for your business intelligence or view or real-time view of your data. If you need some data transformation, you may have in the middle, in parallel to the data flow, some IoT application that for us are implemented extending the concept of Node-RED. Node-RED is a Node.js tool that allow to visually code, design your data flow application as reported here in the slide. From the data flow, you can exploit big data analytics based on machine learning, for instance, or other artificial intelligence techniques developed in RStudio or Python, whatever, and you can develop this tool directly online, exploiting the Snap4City application and tools, and deploy them as microservices for the flow. So the two aspects, the data analytics and the flows and dashboards, are all connected together, all well integrated with the clicks you can pass from one to another. So the platform architecture is described in this slide, and you see the layers of the platform. So from the bottom level, you see a lot of connectors like GIS, city utilities, open data, legacy, personal data, IoT, brokers, KPI, industry, social media. So all these connectors are bidirectional. So this means that we read the data from GIS, but we also provide data from geographical information systems, exploiting WFS, WMS. So it's possible to interact with your GIS. It's possible to work with your city utilities, exploiting external services and getting data and pushing data to them. It's possible to interact with the open data, so to collect data and to publish data. For instance, CCAN is one of the channels active in this sense. It's possible to connect with any legacy service that you have. It's possible to connect your personal data. Personal data could come from database or could arrive from some devices. You may have your bracelet or your smartwatch or whatever. So the system can be connected to any kind of IoT, IoA network. So this means that you may have some connection with the external brokers, with brokers that are not strictly connected with the Snap4City platforms, but are different kind of brokers. For instance, 1M2M, Sigfox, or others light M2M brokers, or brokers for meters or whatever. So you can connect any kind of brokers to our brokers. So we can connect with the gateways, we can connect with the brokers that are on your premise, and so on. We also offer some brokers, mainly IoT Orion brokers, that is FIWARE compliant, and we support most of those brokers with a wrapper that guarantee the security in terms of end-to-end security from the device to the user interface of the platform. So we can also ingest and export KPIs of different kind of KPIs, structured and not structured, and they can arrive from database or from messages or from other things, and they can be exported in several different manners. We are also compliant with a number of protocols in the field of Industry 4.0, like ODB2 or Modbus or OPC-UA or others. We are also integrated with social media, for instance, for posting on Facebook, for getting data from Twitter, or sending messages in several different manners. So all these data are ingested and can be, let's say, exported, can be made available for your devices, for your legacy tool that you may have in the city. And once the data arrive in the system, they are managed by special tools for IoT management, data inspection, user engagement. If you engage the user through the mobile apps, and all these things are GDPR compliant. So the data harmonized are reconciliated in the KM4City data aggregation model. KM4City is an ontology, multi-domain ontology that allows to maintain a relationship of all the entities that you may have in the city. So the knowledge base, the KM4City knowledge base, is a sort of expert system of the city that model all the aspects and refers to big data store. So big data store could be of different kinds, mainly Elasticsearch or HBase based. So all the data that is collected is made available for your big data analytics. You can create your own data analytics, or you can exploit our data analytics. For instance, for prediction, anomaly detection, what-if analysis, traffic flow reconstruction, origin-destination matrix computation, social media analysis, computation of the offers versus demand of mobility, environmental data analysis and prediction, creation of heat maps, routing, multimodal routing, alerting, early warning, also for stimulating your user with a personal and virtual assistance and engagement, and to create a smart solution, smart sharing, and participatory process in your city. So all functionality related to the results of these analytics and the former data that are ingested into the system are made available according to the privacy and rule, are made available through the advanced Smart City APIs for web and mobile applications, for dashboards, and through microservices also for workflow designed in terms of IoT application, as mentioned before. So it's possible to exploit all the data, former data collected and also derived data from the analytics for developing specific tools, or for developing user interface and so on. So on top there, you can create your user interface dashboard for the measure, for the assessor, for the decision makers, but also for the operators. So different kind of dashboards that can be visualized from video wall, large video wall, multi-screen, several inch on the wall, several screen connected together, or you can use multiple views on the same console with the operator with the 3-4 monitor for each. You can use the dashboard also on the dashboard builder to create your mobile app directly from dashboard, so web app, instant app, so that you don't need to compile any code or put any code on your mobile to use the dashboard. On the other hand, you can create your mobile and web application exploit Smart City API and also micro applications directly from HTML5 and JavaScript that use the Smart City API of Snap4City. So if you have the support for the Living Lab, if you need it, you can create an intelligent Smart City Living Lab with a team of stakeholders that could access to the whole functionality of the system to create a new IoT application, which are the intelligence behind the dashboard, or to create a new dashboard, to create a new data analytics, to share with the Living Lab support and resource manager to share this information each other, so the IoT application can be exchanged, the data analytics can be exchanged, and the IoT applications are also used to create a connector and data transformation from the data you obtain from the several channels below to bring data not in the original form, but also maybe transformed according to data-driven approach and so on. So all the whole platforms also includes a number of tools for monitoring, guarantee you the GDPR compliance, security, privacy, the assessment of everything and the self-assessment for the users, the auditing of any activity, and the monitoring of everything is going to happen. Also, the Snap4City portal, snap4city.org, also contain a large number of test cases, scenarios, videos, hackathon, open source stuff that can be shared, and training tools that can be obtained to learn how to work with the platform. So regarding the interoperability, you see in these slides which kind of data can be ingested in the Snap4City infrastructure. You see the connection to the brokers, the connection to the IoT edge device, the possibilities of making web scraping, the possibilities of connecting Snap4City with the CCAN, to collect and publish automatically open data, the possibilities to back and forward, all of them, the possibility to connect Snap4City with GIS sources, also to publish GIS information, the possibilities to interact with any kind of external APIs you may need to exploit, the possibility to access to the REST code or to connect the Snap4City with the mobile app, to access to external and internal data store, and also to access to linked data, linked open data. So the Snap4City also may export the data in linked data, linked open data, since it has a knowledge base that represents the whole knowledge base related to the city. So from one hand, on the left, you see the main sources, or data sources and data flow. From the right side, you see how the person can interact with the dashboard, the tools, and mobile app. So Snap4City is compliant with and interoperable with a large number of protocols. You see them listed in the slides. In reality, we reported here the families of different protocols of different kinds. So it's a mix-up of protocols for IoT, such as IMQP, CoAP, MQTT, 1 and 2M, or Sigfox, LoRa, the Things Network, NGIS, obviously, and so on. You can see also protocols from Industry 4.0, like OPC UA, OPC in general, or WebSocket. WebSocket is also used in the IoT recently, and also for the user interface. We are also compliant with OBD2 for tracking vehicles, SVG for custom widget. So we are compliant with a large number of protocols at different levels. There is a dedicated web page that is web page number 65, on which you can access to see the list of protocols and how we can collect, ingest them, and produce data passing through those protocols, how it's possible to work with them. So Snap4City is an official library of JS Foundation for Node-RED, is an official platform for Fireware, is a gold member of Fireware Alliance, is also an official APIs from E015 of Regione Lombardia for the API infrastructure they have, is an official platform of the European Science Cloud of the marketplace, as reported here on the bottom, is also a platform of Bismarck City, and so on. It is compliant with the Sigfox, it is compliant with the CCAN, it is, we have an agreement as a University of Florence with the ESRI, passing through the LabGeo in GJL of the University of Florence with an integrated lab. This is a picture representing how we presented, how usually we are present in Barcelona Expo World Congress, Smart City Expo World Congress. This is a couple of pictures taken in November 2019. We are going to be again in Barcelona, we hope, according to the COVID-19, and with a larger stand than what we had in the past. So the slides regarding the course, this course here of 2020 are available in the page 577, and the Italian version in Italian language, former course, that means not very updated, is in page 485. We are going to show the video and the slides at this page, 577. So this is the former course for 2019, erogated and produced for Smart City World Expo Congress. And now we start describing, providing you an overview of some of the scenarios that we have developed by using Snap4City. The main scenarios, the first scenarios describe what we have done in Florence. Florence is the location in which we are, from which we started, and so we have a special care of what is going on here in Florence. Wonderful picture. So Florence, we are providing the Smart City control room for the measure, as depicted in these slides. The measure is depicted in these slides, that is touching his control room main dashboard in Barcelona in the 2018. Presently, the 2019 version of the control room is represented in this slide. There is also a link, but the link doesn't allow you to enter and to interact. This version is the actual version, so it doesn't change it for the 2020. So we added some features in the lower level, but not at this level. So from this level, it's possible to see the parking status, percentage of occupied place in the parking. You see that some of these parking area are very busy usually. We have the status of the accidents in the area. Each tile, each widget in this dashboard is interactive. If you click on one of those, you can jump to other views with more details. We have an area with governmental data like number of borns, number of foreigners, number of deaths, number of, this is referring to the 25 October 2019. The number of maintenance activity, number of notification received, and so on. So there is also civil protection status for recharging station and the number of users using the Wi-Fi, and the status of traffic entering in the city and also entering in the restricted traffic zone. Typically, we have in Florence, in a regular case, 280,000 vehicles entering in the city every day, entering and exiting in the city every day. There is also a number of data for KPIs for monitoring the quality of public transportation, with assessing the mean average time for waiting at the bus stop on the measure lines, on the 6 measure lines. There is the possibilities to access to a set of features for energy, environment, as a second level, very complex, very sophisticated views for making analysis, analyzing the energy, the environment, mobility, social, and resilience aspect of the city. The dashboard for the control room in Florence has been developed in collaboration with for Replicate, a project of the European Commission that is one of the flagship projects in Europe, and the dashboard as depicted here in this picture is connected, as I told you, to several other views and dashboards, so you can pass from one to another just clicking on the dashboard and passing to the other views. The views reported in these slides are those at the first level, so over the Firenze main dashboard. So some of them are going to be shown by me. There are views for energy, environment, mobility, what-if analysis, and so on. And one of the most interesting is the mobility environment what-if analysis that is reported here in the view. You can, in this case, define a scenario, for instance, limiting the access to a given area, and you can also compute some routing, dynamic routing, for deciding how to change the viability of a certain area if there are some blocking perimeters that would like to be avoided for security reason, or you have just decided to change the viability in some part. So in this case is also depicted the NOx heat map that show how the traffic is producing pollutant in the area of Florence. So from a selector on the left, you can change and activate any views you like. You can just jump again to the main dashboard. You can see temperature. You can see, as I am going to show you later, you can really navigate in the data of the heat map with the Prev and Next. You can control all the widgets that are going to happen. You can change the map behind your representing your city in the background. You can save your what if analysis. You can reload your what if analysis and so on. So what if analysis for routing, for dynamic routing, you can define a blocked area like this one and see what happened in passing from one point to the other. If there are alternative paths, can be calculated dynamically. You can save and share with your decision maker to discuss about what is going on, what could be the best solution to do it. So the Smart City Control Room in Florence collected and exploited a large number of data regarding mobility and quality of public transportation, traffic flow, smart parking, accidents. Regarding these are the main data that is addressed there. There are a lot of other data that are not listed here. So environmental data like come from irrigator status for smart waste, from sensors, environmental sensors, several different kinds, PM10, PM2.5, NO, NO5, CO2, and so on, pollination. We compute heat maps from those pollutants. We compute also NOx prediction from traffic for predicting the pollutant. We have also data regarding recharging station, some consumption of meters, smart lights, street lights, weather forecast and actual data for meteo and forecast, social information coming from the smart benches in the city, entertainment events. We have also events for traffics that are not reported here, but we have, are shown later on. I am going to show them. Twitter social monitoring, TV camera streams can be integrated as well. Status of the triage for the hospital. This is more than social, is a healthcare. Monitoring from COVID is also included, and people flow from Wi-Fi and from other information from apps. We compute the origin destination matrices from people flow to understand how the people are moving inside the city, and also we have connection with some KPIs to collect in some KPIs to show the digital signage or to send the information to the digital signage is also possible. To have a connection with the civil protection data, to the possibilities to collect, and we have collected all the point of interest in the city, 100,000 of point of interest with regarding tourism, restaurants, hotels, any commercial facilities you may have in mind is listed there. There is also a tool for making analysis and so on. So this is an example of how the system can be used for early warning, just monitoring the tweets. We have the measure of the city that is very active on tweets, and it's possible for him to see it, to have a direct view. But if you are not used to be really care about the flows. The system can inform you if there are some inception of big number of tweets coming on different kind of thematics areas. So it's part of the Smart City Control Room. I views also on the volume of tweets on different specific channels. So tweets can be also used for with the predictive capability for the hot flow, for the attendance to events, and also for as an early warning tool, obviously. So this is what happened in the Lugano-Torrigiani. It was not, in this case, the social media was not really useful because it happened in a moment in which the people were all in the bed. So 3 in the night was not possible for everybody to monitor or to harm what has been done there. But the information arrived to the measure from the civil protection, and the city reacted very well to the even on the exploiting a part of the results we produced in the Resolute project activity with the municipality. And this is the dashboard we developed in that case. It was in place for the case. It was an unexpected event. This dashboard monitor is a resilience dashboard that put together the flow of the people with the traffic flow, with the social media aspect, with the Twitter indexes, event in the city, and also triage contextual information and all the activities regarding restoration and let's say operative and the events in the city regarding the maintenance of the city and construction or incidents or accidents in the city and so on. Civil protection monitoring, environmental data, and other information just in real time. The activity we performed in this context for the early warning was focused on creating the European resilience management guidelines that are available for everybody in open source, and to create an operative manner of managing this information flow for anticipating, monitoring, responding, and learning about any kind of disaster, natural disaster, or let's say human-created, human-based disaster like terrorist attack and so on. So the European Resilience Management Guideline has been tested against the cases in Florence for flooding, but also for Athens for the metro. So you can access to the Resolute projects to see those tools. In Tuscany region, and mainly in Florence, Pisa, Livorno, and Prato, we have a number of facilities. In Tuscany, we cover with data the whole region with the whole details regarding traffic and pollutant, and also triage and parking, and many other information regarding mobility, social, hospital and triage, environmental, culture and tourism. And we have a couple of apps that provide this service to the citizen, and the dashboard for the operators. On the basis of the data of the apps, we compute these maps for origin-destination flows to understand how the people move in the Tuscany area, and where the people go when they leave the Tuscany and they go in all the other parts of the world. These are examples coming from Pisa. We do traffic flow reconstruction in Pisa on the basis of the sensors that are located in the blue hotspot here reported in the map. So the traffic flow reconstruction is the activity that you measure the single traffic flow sensors, and on the basis of that, with some partial differential equation solver, we extrapolate the whole flow for the whole city. And the whole flow, the traffic flow is reported above, while it's also used for estimating the model that is called the GRAL for predicting NO2 diffusion, NOx diffusion of pollutant in the city. So it is represented with an heat map as below, with standard calibrated data according to a resolution of 4 square meters, and considering also the shape of the city in terms of 3D shapes, the direction of the wind, and other details that allow to produce a quite precise diffusion of this pollutant in the city, provoked by the pollutant produced by the cars. This is the same performance in Livorno area. We do in Florence, in Livorno, in Pisa, and also in Helsinki for the PM10. This is the Helsinki view. These are what we have more or less in Helsinki in terms of pins. In Helsinki, we have a number and information regarding mainly on environmental and weather aspects, PM10, PM2.5, NO, SO2, CO, noise, and others environmental variable. Some of this data came from the infuser from the Finnish Meteorological Institute. And we do also GRAL prediction of PM10. We compare the data predicted by Finnish Meteorological Institute and our solution to see the differences, mainly in the area of Jätkäsaari area. The data that we collected and show in the Helsinki area also are related to mobility, with traffic sensor, operator routing, multimodal routing, what-if analysis, also in this case. So we collected data regarding tweets. We create a dashboard for that we call Life in Helsinki. So to see how people move, which are the hot places in the city, and so we also have a large number of data regarding tourism and culture. You see the restaurants and the hotels and bus stops and meteo information. So a lot of information that is also provided to the citizens by using the mobile app for citizen, tourists, and so on. So this is one of the dashboard of Helsinki that allow to see the city overview. You can jump from one dashboard to the other using this button to jump to the forum discussion, to the surveys, to the documentation. You can click on each point of the heat map you select to see the value in that point specifically. You can select different from the selector, bus stop, TTEC sale, with weather sensor, air temperature, humidity, several kind of heat maps. Some of the heat maps are represent predictions, like those produced by the infuser Finnish Meteorological Institute or GRAL. Some of the heat maps are focusing on a specific area of the city, and so on. So it's possible to see real-time cameras and so on. You can play with this kind of dashboard directly accessing to that link reported below. Every time that you see the link, you can use it. So you can, if you download the PDF version of the slides, or you use the interactive version of the slide, you can jump on those links to use them, because most of them are public. So this is another dashboard, very similar to the previous one. In reality, it has been cloned to the other one, and we have changed the look and feel, just selecting the different modality by using icons instead of a selector with the text. It is probably more dedicated and more easy to be used and more nice and to be used with the nicer icons on the maps, less with the different styles in general. You can have more white and clean views with the same tools, with the same dashboard builder. It's a matter of a preference to use one modality or another. We do data analytics in specific point, comparing the infuser and Graal for understanding the prediction, how reliable are the prediction for PM10 and in general. So it's possible to have this kind of extraction point by point of the data regarding pollutant. And this is a good service because it's also possible to create a smart routing, for instance, for suggesting which are the cleaner street in which you can go with your baby, or you can run if you are a runner, to spend a part of your time in training yourself. So this is the Helsinki Life of Helsinki dashboard, accessible here from the link. You can play with the different views. You can go in the high quality, different kind of value and reference value in the point in which you click, or in the point in which you are. You can move in the city and check point by point the status of the high quality in a specific point. You can otherwise you can go in the flows and see how the people typically move at a given time from another part of the city, where they go, how many they are, and so on. You can understand how the city is used by the people. That data are collected from the mobile app. So if the app is going to be very, very diffuse, they are strongly representative of your city. This is an example of predicting pollutant in the street. You see the high resolution and the fact that the pollutants are in the street and not outside. So this approach takes into account the 3D structure and is based on Graal model, that is a partial differential equation model for traffic, for pollutant distribution and flooding on the basis of the wind and so on. In Helsinki, we also collected data coming from sensors that are managed by the final users. This is an example of a sensor placed on a windows of a covered terrace, balcony, and so each of them, this is the sensor identified by this number, each of them has a special views on their value of their sensors over the time and real time, so they can also see the other sensors in the area in which they are. This is the Jätkäsaari area, and they can access to all the services that are in the area. And so this is the dedicated dashboard, the private dashboard provided to that person. So the mobile app in Helsinki and also in Antwerp that I'm going to show later allow the user to see similar information, to see the heat map, to access to the heat map, to access to the dashboard, to analyze the information, to navigate in the area, to click in the several parts of the city, and so enjoy to routing or taking a transportation information and so on. So the dashboard the mobile app are also used to push the people, providing some questionnaires, engaging them to react to the stimulus and so they can provide comments and appreciation, or just assess what we provided. This is just an example of a questionnaires that have been distributed in Helsinki in the last year, after few moments after the starting. So we collect also text. So it's possible to collect text to understand what they do, to collect their feedback. In general, is the monitoring of the app allow us to understand how many minutes they use, how many days they takes to returns to the usage of the apps, which kind of area they prefer to use, if they ask more on environmental aspect, or on assistance, or on search facilities, or on transportation, and who is going to ask, those that speak the local language or the foreigners, in a way that we can understand which are the needs of tourists with respect to the needs of citizens. And there are some technical issues regarding the distribution, and also regarding how many engagement they have accepted, or they have received, or how many tracks, how many trajectories inside the city have been collected day by day. So in Antwerp, we have a similar activity that in Helsinki, with a similar density, especially in the downtown of Antwerp, in the smart zone. The smart zone of Antwerp, in which we concentrated our attention. There are in Antwerp a number of sensors in the whole Belgium area. For Helsinki, we have sensor. We collect data from sensor from the whole Finland, and similar in Belgium. Sensors are mainly for air quality or weather, but also for the status of the tunnels and the bridge, mainly for tunnels, and the ferry crossing the river that is actually used as a port for Antwerp. So big ships are moving there. So there are a number of information that you can request to be shown, and if you select, for instance, temperature in 3 days, you can see the trend of the temperature depicted below. You can pass to the other dashboard on the left. You can see the heat map. This is the heat map regarding the humidity in the city. It's colored according to the value. You can see also the distribution of the European Air Quality Index, or different kind of European Air Quality Index. Maps for biking safe, or routing scenarios, or what-if analysis, also in this case, but also in the other dashboard as well. This is another example with changed look and feel, with different kind of icons and user interface. Another one, again, you can change the icons, you can change the icons. You can have the same icons on menu and on map, and you can adopt and select any color you like to have on the screen. It's also possible to have a technical view like this. It's very similar to what you may have in a GIS. So with selecting the layers to be shown, and also again to see the trends. So if you select some of the value here, the value trend is depicted below, in the graph below. You can have multiple of those maps and those trends, or whatever. In Antwerp, we collect data regarding environmental, mobility, and also PAX counter. PAX counter data is specific for Antwerp, in which they have 22 different PAX counter, such as those reported in these slides, for monitoring the people flow in the city, with the measure museum and services there. There is also a dashboard for life in Antwerp, similarly to that of Helsinki. A lot of data regarding tourism and culture and service in the smart zone, especially, and the Antwerp in the Snap in all stores available. So the example of the PAX counter has devices for sniffing the number of people passing by in a given area according to some sensibility, and they provide this data through LoRa network, and we collect this data and make analysis and provide this data directly on dashboard. Some of them are mobile, like those circulated here in the slides. Mobile means that they can be taken, put in a pocket, and work in the city and monitor, making measures of how many people you are meet. This is a tool for policemen that are moving during manifestation or attending some sport facilities to understand how many people attend a given event and so on. All these data are collected, analyzed, and reported in dashboard, and some of those devices can be programmed to be to change the sensibility, the area, or the period in which they count the number of distinct users sniffed on the device. These activities performed through an IoT app. That is something that I am going to describe you later. That is the part of intelligence. We already stated that the data flow can be transformed, and the data-driven application can be used, but also can be used to put intelligence behind. So some of those pictures here, some of the control elements in the dashboard have a direct counterpart inside the flow. So if you click here, you create a message into the dashboard. This is an example of the data collected from the services in Antwerp for monitoring the mass museum and monitoring also the others with different trends. And this is an example of flows in Antwerp as well. Similar to what we discussed for Helsinki, surveys and monitoring for the usage of the apps with different kind of data. This is an example similar to what we have done for Helsinki with different kind of facility, and you see the traffic flow, the people flow moving in the city, how they move from the downtown part, where they move according to the time slot. If you are looking for inflow or outflow, you can make an analysis of the flow of your people in the city. Another example in Prato. Prato is an application which integrates the smart city aspect and the Industry 4.0 aspect. In this case, it is a depuration, water depuration plant for GDA, for the whole industry area, industrial area in the Prato zone. They have a water plant managed by Modbus. So this water plant needed a telecontrol to telemonitoring what is going on. Typically, these plants are very spread, are very large, and so you can have the needs of monitoring and mixing together the information regarding the plants and what is going on to what is going to happen, what is occurring in the city in terms of environmental variables or others. So for these reasons, we created this mechanism to have synoptics panel, interactive synoptic panels, and at the same time in the same dashboard information regarding weather forecast or regarding pollutant, and with the possibilities of analyzing the status or see the temperature trends and so on. So Santiago de Compostela is another example. There we computed the traffic flow reconstruction on the basis of the position of the sensors. With the partial differential equation, you see the single segments is a way to report the single segments, but it could be the segments describe the traffic flow density. We could also describe the velocity of the flow. In this case, only traffic flow density is reported. This information is also exported in numerical and not graphical manner, but we are precise numbers to be used for prediction as depicted before. Lonato del Garda is another example for this, in this case, smart parking. Smart parking has a synoptics which reports the status of the parking lots and also to identify longer parking or the over parking, number of free slots over the time, and so on. You can put together this with the temperatures or other, you can monitor. You can see the cameras from the direct camera from the parking area and the synoptics with the animation when the car is disappearing or different color if you can code, if you can have the information regarding the overparking in that slot or with respect to the meter of parking meter that you have put in place. So many different cities. We are adding recently other 6 more cities, and we have a number of, as mentioned before. So they were just those presented in this part, just example. You may have a deeper view of the scenarios accessing to this web page, in which you can have the list of the scenarios and also some PDF files that you can download with the schema of the scenarios, with the description of the scenario. The web page linked here contains more information than what you can collect from the PDF, because that part, the PDF has a limited space for 2 pages. So go ahead. What has not been mentioned in those scenarios is the huge amount of data in other locations that we manage, like so mobility, underpasses, ferry, tracking on bus, delay of bus, OBD2 tracking, mobile trajectory, bike sharing, connected driving, type sharing in Siena and Pisa, connected driving, fuel station price, sensor of different kind, heat maps of other different kinds, social information, clicks, ranking, entertainment events, people flow, governmental information, tourism, and much more. So many other data are managed inside the platform. So this is just to remind that the architecture now could be more clear what has been used. Entering in deep of the architecture is allow you to collect any kind of data source in pool, so go to get the data, or just to receive the data and push the data. All these data are collected in with different modality according to what you prefer. We are preferring recently to use IoT application not only for the workflow, but also for the data ingestion. So you can be uniform in data ingestion and data transformation. So event-driven data or pooled data are put in the knowledge base and into the database. Database could be Elasticsearch or based on HDFS, HBase Phoenix. We recently prefer and push for Elasticsearch mainly because it's much more flexible and easy to manage, and HDFS and Phoenix is probably for very huge smart city. But we can have both. So you can have both, or you can have one of the others, depending on what you would like to have. So the storage, the collect all the data, and the index performed semantically inside the knowledge base, and these allow to perform queries, semantic queries, and semantic queries are available for and Smart City APIs are available for all the dashboards you may have here, and also for the IoT application that you can realize exploiting the data. So you can, through the IoT application and dashboard, you can really be bidirectional with the events you may have. And so your front end could be dashboard and apps, but you have also from Snap4City a number of tools here for controlling and managing your smart city. This is very important. So now I think is more clear what we intended with the mechanism, dashboard, IoT application, data analytics that create the new data, new knowledge, and hints on what is going on, and the world of data on the left side. So if you develop the IoT application, you can exploit a large numbers of nodes and functionalities that allow you to exploit and to code visually, so to program visually all the workflow and data transformation, to put any kind of intelligence you may like to have behind your dashboard. You can react to condition. You can create a flow that could define file condition and control condition and the harm on your of critical case on the dashboard, or send messages, email or tweets or SMS to your operators. You can also send a message to your ticketing system, to your management ticketing system. And so you can, from the workflow, you can interact directly with the dashboard, with those electric blue widgets. You can directly interact with the Fireware Orion brokers. You can interact with any other kinds of brokers for MQTT or COP or M2M tools or others brokers that you may have. You can connect them very easily. You can save the data, you can collect the data. For instance, you can ask to the system which is when the next bus is coming, which is the transportation public routes, where are the bus stop here, where is the restaurant close to me, where is which is the transportation timelines. Do you have a new open data for these kind of topics? You can code everything. You can define a workflow of everything, action on the mobile and dashboard, or action that need to be taken on the basis of events occurring on the field through the sensors, or on the file through your external services, whatever. These are examples that have been created by the municipality of Florence. They have a number of experts now that are capable to autonomously develop some IoT application exploiting the platform. This is an example that put together some flows behind an operator dashboard that would like to control speed limit and the red light in the street, I'm going faster. And these are some IoT devices. We are going to talk about those things in the specific section. Data analytics, a lot of data analytics for people flow prediction, traffic flow reconstruction, prediction of pollution, parking predictions, matrices, origin destination matrix, prediction of city area or attendance or others kind of prediction. This is a map as a table describing how the data analytics disappearing, not evidence for the users. They have been erogated for different kind of users in Helsinki and Antwerp, for city officials, for ICT officials, for developers, for business owners, and so on. What they have the opportunity to see, and which is the main source of data on which this information is provided, how it is computed is. So a lot of different data analytics has been created in a transparent manner, very easily to be done. So the system allow to accelerate, to exploit the mechanism of the living lab, to create a new smart city, or to leverage the smart city that you have with a new level of functionalities and capabilities. And typically when we start uploaded data, connected them to IoT, connected external services. At the same time, you start collaboration, agreement, and networking, and tutorials. And then we go in parallel with these two activities, creating workshop, ingesting data, creating advanced smart city APIs, creating some experiment, so producing IoT application, creating case studies with research groups, producing apps, and creating partnership with the startup, monitoring city platforms, creating hackathons for creating new activities, promoting application and dashboards, and going in to create a community. This is the process for accelerating your city to become a real smart city with the support of our Living Lab. So for the support with the Living Lab, you need also training. Training is available on the web portal as this training. A lot of material is available, not only slides or videos such as we are recording this morning, but also many other test cases and hackathons. This is an example of the training in the July of 2019. It was supposed to do also this year something like this. Now we are in a smart working, and so we do that fully online for everybody. So this is the training set and so on. So behind the solution, there is a development, mobile and web application and smart city, let's say, development. And from the left side, you see the analysis area, data analytics, development of IoT application and dashboard and deploy. This part here is mainly for creating the smart city services, and then on the basis of the smart city service, you can create your mobile application. We are going to describe this in deep in the successive parts. You can adopt the smart city, the Snap4City. You can install you can ask to us to provide you smart city as a service on our cloud, or you can download and deploy your solution whatever you want. You can even start on cloud and then ask to move outside, bringing your data with you. This is possible. This is our roadmap. We started in the 2013 with creating a lot of activity. Mainly we started with the creation of the KM4City ontology and the first data aggregator. In the 2015, we took the Resolute projects, exploiting the infrastructure, and then the C-Mobility project and challenge, and then replicate other flagship projects. We became compliant with the fireware, and a lot of projects and tools and cities connected to us during this roadmap in which we are now in the 2020. So in the 2017, we changed the name because we started the activity of integrating the aggregator that was called the KM4City in something that included also the IoT stuff. And so we started the activity with the Snap4City in the 2017, a new version of the ontology addressing IoT, IoT Hub, all the new push regarding mobility with the Mosaic, with the 5G, with Drive-Fair, with the environment, with the open science cloud, with SmartBed, with the BSmart, with the 5G project, with the Reverberi for Lonato. And then we took the award from Helsinki, Copenhagen, and Antwerp. The award we resulted to be the winner of the pre-commercial procurement for Snap4City that started in the 2017 and finished in November 2019 with giving us to the winner plate. Now we started also another activity with the Interact. So these slides report some of those references with the project, co-founding, qualified partners, technical partners, and marketplace. I am finished here.